Hi and hello everyone. Welcome back. I know this video is after a couple of months, but for you, I have just changed the topic, moving towards algorithm. I understand that you have already understood the syntax specifically of Python and you have learned the flow controls, object-oriented programming, data types, decorators, constructors, and a lot of other topics in Python. Moving towards algorithm is a major step because now you are implementing real world scenarios or you are trying to solve real world scenarios or just about to solve real world scenario. And this is the starting point. Within algorithms, I have chosen sorting algorithm. Sorting algorithm is just simple mathematics. We know we can easily sort it uh, in different scenarios. Just for example, taking the smaller element first and then moving upwards. But we want this to be done through Python programming language. And one of the you can call it easiest method within the sorting algorithm is bubble sort. We're going to begin with this picture. There's a list of elements 8, 2, 6, 4, 5, but this is not sorted. We want this to be sorted. In bubble sort, what we do, we actually compare adjacent elements, and the smaller one is shifted towards left hand side and the bigger one is shifted towards right hand side. This comparison of adjacent elements continued up till all the elements uh, of the list are compared. So in the first iteration of comparison, the first two elements, like we know that in Python list we have an index starting from 0. So this is the 0th index, this is first index, second, third and fourth index, and all the elements of this list are 5 total. But starting from 0, it means the last element will have fourth index. So 0th index 8 and first index 2 are compared. 8 is greater, so 8 would be shifted towards right, and 2 smaller is going to be shifted towards left. Now then 8 is compared to 6. 6 would be shifted towards left and 8 towards right. Then 4 towards 8 and 8 towards 4. And then 5 towards 8 and 8 towards 5. This iteration cycle is complete. But we understand that the sorting has not complete because we can see here 6 is definitely greater and 4 is smaller. 5 is greater and 8 is 5 is greater than 4, but it is smaller than 6, but it is coming at the end. So sorting is not complete. We're going to sort again, do the next iteration and do the similar comparison again. 2 and 6, it means this is already sorted. We are not going to do anything. Then 6 and 4, 4 would be shifted towards left, 6 towards right. Then 6 and 5, 5 would be shifted, and then 6 and 8, nothing would happen. That means sorting is complete. Now, what if the comparison at the starting point, all the items are sorted? How do we know that? So, at the start of the code, you're just going to write down and check if it is already sorted or not. So within first iteration, if all the elements are, if our condition of this number is not greater than this number turns false, then for all the first iteration, then it means we already have a sorted list, and we're going to create a flag and mark it as sorted, and we're going to end the code. So this is the scenario. Let's implement this. You will have a better understanding while we implement it. Okay, so this is our bubble sort algorithm. Okay, let's create a function bubble sort, and we're going to take a list as an input parameter. Okay, first of all, we're going to check what is the size of list. So we're going to create a variable n, and we're going to use the function len and pass list into it. So this will give us all the elements, the total number of elements in the list, or to the total number of items in the list. Now we're going to start a loop to start iterating or checking the adjacent elements. Let's create the loop for I in range, comma. Now this range is going to continue up to, for example, there are 5 elements, 1, 2, 3, 4, 5. But overall, if we consider its index, it's 0, 1, 2, 3, 4. So there are 4 actually. So we have n is equals to um, the list, number of elements in the list, minus, you're going to minus it I and then 1. So what will it do? For example, if there are 5 elements, it is going to subtract 1 definitely from it. So that would be 4. So we do not get an out of index error, because if this is going to continue up to 5, there is no index fifth index in this list. So we need to subtract 1 from it. Now we're going to consider that it is already sorted, and we're doing this because if it is not sorted, or if the condition is true, we're going to turn this flag to false, and the loop should continue. So for k in range, now this is another loop. So we have two loop, external loop and internal loop. But internal loop, what it does, actually we'd be checking and comparing all the elements within the internal loop, and checking if the adjacent elements are, which adjacent element is greater or not. So okay, so just bear a moment while I'm writing the code. So I'll explain this in just a moment. Actually, so what we have done, we're comparing the first element. It is going to start with 0 and list at the 0th index is going to compare or check if it is greater than at the first index. If true, so it is going to enter the if condition, and we're going to swap elements. So at the 0th index and at the first index would be swapped to 0th index and 1 index. And since this condition has come out to be true, so we're going to mark this all sorted to false, because this is not actually sorted, and this should continue the loop. Now first of all, it is going to start with 0, and 0 plus 1, that is 1. The loop would continue. The next time it comes, now it is 1, and this is 1 plus 1, 2. So it is going to check again, then 2, 2 plus 1, 3, and then 4, 4 plus 1, 5. So if there are 5 elements in it, 5 minus I is 0 actually first time, and then 1 is up to 4. So this loop is going to continue up to 4. So first iteration is complete, then it will be out of this loop and will enter the external loop. So now it is 1. So since we've already done the iteration, first iteration, we would not need to compare it the last element because that has already been done. So therefore we are subtracting here I also. So we do not have an extra iteration at the end. In the first, when the first iteration is complete, and it does not enter if means this condition of adjacent elements being uh, first adjacent element being not greater than the second adjacent element, and for all the elements within the list, so it will not turn this flag to false. And since this flag is not false when when it comes out of the loop and it checks this condition, it would break. That means this is already sorted. And when this is sorted, we are just going to return and list. That is the list that we passed. So let's run this. Okay, I've got an error. Break outside of loop. Let's test this. Let's create a list 3 comma 9 comma 2 comma 1 comma 5 comma 4 comma 7. 7 comma 6. Okay, and let's pass this list to a function pub underscore sort. So list. Okay, here we made a mistake. So that should be no. Let's run again. 1 2 3 5 6 7 9. Perfect. So okay, I hope you enjoyed it. This algorithm was a simple one. We just needed to implement a simple logic, but it tested our uh, understanding of flow controls because we definitely implemented for loop, we implemented if condition, we implemented break. So definitely tested our understanding of flow controls. I hope you have a better understanding. May you have any queries, feel free to get in touch. And if you find difficulty in implementing flow controls, you can refer to my course of flow controls in Python. Thank you.